what I want to share today is some demos that I have done in the past or have been taught. I have to thank a couple people up front. One would be Dave Black, who is a technical artist at Firaxis, or at least he was when I worked there 8 years ago. It's possible he's got a higher up position now because Dave's the man. I don't even know if he's still there, but at the time, he was a good guy. Good guy. Didn't take any BS from anybody, knew his stuff very well, and made some excellent scripted tools for us. One which I deeply miss, which was called the Dave Black Mega Connect script. Man, I need to call him up and get a copy of that tool. Anyway, hope you're hoping to join us a little bit. Also have to thank Greg Furch, who was an art director of mine back in 2006-7, who encouraged me to learn more about 3D modeling. He also helped me get my internship uh, at Firaxis in 2003. He was the first recruiter from Firaxis I think I talked to back in 2003. Me and Greg have sparred over the years as I got better at modeling and he became more of an art director, but I must respect the man for getting me my beginnings back in the day. I think it's important in this time to remember the whole timeline of things. So let me check the stream, make sure you're with me now. Hopefully this works. Let's see how this goes. I'm a little confused because I have the different setup today. Usually I have the screen sharing Photoshop on my right monitor and my left monitor is all my stream management stuff, but today we're doing Max, so we're streaming from here. Make sure I am recording with the open source broadcast studio. It looks good. We're recording. We can see Max. We can see my face. How's that camera look? We see Cityville 2, a game I worked on back in the day. Fan is off, so hopefully there's no audio issues going on. What I would like to do is tilt this back a little bit so you're not looking at my chest and more at my face. All right, that's pretty good. Let's tilt that a little bit more. Tilt that a little bit more. Get the American flag in the background. Excellent. So what I want to talk about today, I've been thinking about for a while doing a quick subdivision demo in Max. And why is this important? So this demo is mostly going to be focused towards my younger 3D students, not my peers in the game industry who already know this. Maybe if you are a peer of mine in the game industry who does 3D modeling, feel free to chime in, tell me where I'm wrong. But for the most part, this is something for the youngins or people who are new to 3D. So in Max, I can edit and adjust 3D objects. I can use different hotkeys to see the different vertices, edges. I'm going to be dropping a lot of geometry terms, and just bear with me. I will be re-uploading this video to YouTube, the Turbo Symonds page, if you want to take a look at this later. Let's bust out some terminology real quick. A point in space is a vertex or vertice. It's a point, it has an X and a Y and a Z location, and in Max it retains data for which triangles it's connected to. So if you remember your basic geometry when you're growing up, any 2 points make a line. So we have 2 edges of this cube. Those together make an edge or a line. You can make a line in Max as well. I could demonstrate quickly making a line. Click, 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 and we have a spline. We can make this line right now is very linear. We can change it to be a curve by adding a Bezier to that, and now we have a curve, and we can do things with this. We can later turn this line into a 3D element by using some other tools in Max, but just wanted to make the point. Any 2 points make a line. Any 3 points with some kind of Bezier math, you can do some curves and exciting things about that. So what happens when you have 3 vertices and a triangle between them? Well, you have a face. So we have, this is a 4-sided face, or a quad. For 4 sides, we use the term quads a lot. What are some specific terms in 3D modeling? The next one, the most important one, is probably loops. So anytime you have 2 parallel pieces of geometry, if you connected those 2 with a line, you start to get some kind of loop math where this, if you divided all these edges together, and I can hold shift and click, I should be able to shift click and it gets all of them. Maybe it's control click. How did I do this? Once upon a time, yeah, there it is. Click and shift click the next one. and then we can connect, and now we have what you call a loop. So this would be a edge that goes all the way around and it comes back to itself. In Max, I can double click this edge and I can select the entire thing, and then using the gizmos I can manipulate and move this element around. I'm actually misusing the phrase element here. Element, it would be a detached part of a geometry. So for instance, if I wanted to copy this face, I can hold shift and move that face. So now I just have a one-sided face hanging out in space. This is all part of the same object. I can move this whole object together. If I copy the object, I have a second object. So you have box 1, box 2. And within that, we have different elements. I can hit hotkey number 5, and I get my element, which is detached geometries that are within the category of object. Say hello if you're checking this out, if anyone sees it. Thanks for joining me today. Looks like Luke likes the video. My man, Luke, down in Tennessee, maybe Mississippi now, my man. Oh, what a good, handsome fellow he is. Today's coffee, Green Mountain Coffee Roasters. It's from Sobel's Supermarket. Had a donut. Excellent. When you go to Sobel's in Shrewsbury, ask for the Khaleesi of the Bakerisi. She makes the donuts. Say hello to her. She thinks I look like Seth Rogen and gives me a compliment on my Seth Rogen-y appearance every day I go in there. So, back to boxes and elements. We have a lovely purple right now. However, I don't find purple to be that clear to demonstrate. What I like to do for these demonstrations is actually throw on a material that will be a little bit more orange. Max 2020, quick rant. I don't love that my default materials are these new architectural materials. I want just general, like I like my old shell materials that came with the old Macs that I trained up on. I know I sound like an old FUD, like an old fogey right now, but I miss the simple, basic, crappy materials because they were easy and fast to work with. This new material editor takes longer to load, and I find it to be very frustrating. I'm not going to go through trying to figure out how to get to that. We're just going to drop on a general gray material right now and make it a little pink, a little salmony orange kind of color. I find that that color is a little easier on the eyes. So let's drop that in, and then maybe we'll have some fill light. Maybe we just make it. I'm getting off the subject. I just wanted it to be a little easier to see. Orange against the gray pops a little bit better. I like the orange-gray color scheme. And then you guys can see very easily what's going on. So without the line overlays, it looks like this. Very hard, sharp-edged. It feels very artificial, doesn't it? Because how many objects in the real world have an edge this sharp? Enter subdivision modeling. Subdivision modeling. I have a couple modifiers right now that are used pretty commonly. Edit poly, unwrap UVW, turbo smooth, UVW map, mesh smooth, volume select. I didn't put volume select there. That's an old holdover. Turbo smooth I do use a lot. Turbo smooth will subdivide this object and smooth it out. So right now we put this turbo smooth on it, and what it did, it turned it into a ball. Weird, right? Well, check this out. This is actually something I want to give Ryan Murray, a former modeler, coworker, friend of mine, both from Firaxis and Stardock, credit for this. He showed me that if you put some loops on the box, so we're going to use this tool, Swift Loop. Josh Hardy, former coworker, showed me where this thing was, the Swift Loop in the graphite modeling tools. Use this tool and it gives you a preview of anywhere a loop can go on the surface. This is a great and super fast way to subdivide. The idea is to add more vertice and edge information to your model to retain the shape while also being subdivisible with Turbo Smooth or ZBrush or all kinds of stuff. So let's click in a couple of what Dave Black would call edge tension loops. So suddenly we have 3 loops, X, Y, Z axis around this corner here, and if we turbo smooth it, we have a rounded corner. This is much nicer and feels already more realistic on that corner because most of the objects in the real world have some kind of softened or chamfered edge. If everything was perfectly sharp, we would be cutting ourselves all the time on everything we picked up. But in the real world, you can see on the lid of this cup, it's a rounded edge and it catches the highlight no matter what angle it's in because it's rounded. Always some aspect of that rounded surface is finding the highlight and catching that light and reflecting it back to our eyes. Hopefully you guys are with us right now. I got some messages I will respond to. At this moment, I want to give a shout out to inspiration. Half-Life 2, Raising the Bar. I did a podcast yesterday with my dear friend Dustin and his brother Devin from Art of Craftsmanship YouTube channel, and they asked me what was the game that I loved the most, and that would be Half-Life 2, as far as best game of all time. Lately I'm playing Zelda, and I've probably spent more time playing Zelda than Half-Life 2 because the game's just bigger. But this was a big inspiration for me in college, and the original Half-Life and Counter-Strike were inspiration for me when I was in high school. But this book was awesome. I think I bought it at Best Buy back when they sold books. And it has some beautiful and weird concept art from the original Half-Life. It's got some screenshots from the original Half-Life. Look how simple those drawings are compared to the concept art of today. This is pretty crude, but concept art was really just supposed to be just that, just the concept, just the idea, and then the modeler would refine the sketch into something that would be playable. So the era of high polished concept art is a more recent phenomenon, I think. Back in the day when you had a small team, you just did a sketch. Like for instance, here's Dog, the dog character. Now Half-Life's 2006. You can see Dog's the sketch and then Dog the model there too. So this book was great. And it's got some beautiful scenery. Look, this is a screenshot from Half-Life, and it's still beautiful. The geometry is simple, but the game is still beautiful today, and I think it's because there is some fundamental good art direction for Half-Life. Who's the original concept artist for Half-Life 2? He went on to do a lot more work with other video game companies. He's a Russian or like Ukrainian guy. Victor Antonov, I think. Victor Antonov. So he did these like creepy, gothic-looking architectural concepts. Dishonored. I think he was lead artist on as well, the concept artist. So back to this. Let's check. How many people are in the chat? Anyone in the chat? Did anyone like this? Is no one seeing it? People aren't as interested in 3D as 2D apparently. That's fine. This video isn't for the 2D people, it's for the 3D people. Real quick, so you can see that when this turbo smooth is on this element here, it is nice and soft, and on the back side it's being curved out and kind of weird. So let's delete that turbo smooth layer again. Let's keep doing swift loops around the geometry. Okay, we have our 3 loops on that corner, 3 loops in this corner. Let's get a 3rd loop here, and then we have them underneath. So edge tensioning. This is what Dave Black talked about, is that depending on how tight these loops are to the edge, this tension, being the tightness of it, will affect how tight that corner looks under turbo smooth. So see, this is a very tight rounded corner now. See that? See how tight that is? How tight that highlight is? It renders pretty nice. And if we adjusted those, whoa, what is going on? Got weird pop-ups all over the place. Let's go look at our edges again. If we brought these loops to be further away, it should soften that. So we're loosening the tension on this corner. Hit the turbo smooth, and now we have a much softer corner. Hope that explains a few things to you guys. The good thing about subdivision modeling, keeping every subdivision, sub-tensioned, tessellated element as a square, is that you can divide it many, many times cleanly. One of the problems with high poly modeling is getting triangles and knots, n-gons, when you have more than 4 sides or less than 4 sides. the math isn't as easy for Max to add more subdivisions to it. So when I put, to give you an example, so Turbo Smooth right now is on one iteration, so it is doubling the amount of geometry. If I turn it down to 0, it is just showing us the geometry that exists. 1, 2, 3 subdivisions, 4 subdivisions. So we can keep adding and adding and adding more geometric information, and it's making a cleaner and cleaner and cleaner render for us. So if you're a car company and you hire a 3D modeler and artist to make a virtual version of your car for a commercial, those car 3D models have millions and millions and millions of vertices and polygons in them to get the highlights and reflections to be crystal clear and perfect. Right now we're looking at a poly count of this of about 33,000 polys and 16,000 vertices just with 4 iterations of Turbo Smooth. If I turn that off, we go back down to 68. So we have 68 polys and 68 verts, poly being flat surface. Hope this is all making sense to you. Now, something to notice when you're subdividing is, do you see how it's very tight? We have an increased density of geometry on the corner where the loops were tight, and we have a less dense amount of geometry in the middle of the square. So what you might want to do on the low end, if you want to keep your distribution of geometry and verts more consistent, is probably keep adding a few more loops along the middle. That's what I like to do. I like to have some kind of quad in the middle of my geometry. So this is good. So we have a tight edge. Let's have a tight edge here on one side and then a loose edge on the other. Let's just see what that looks like. So I'm going to manually select this edge and then bring it up to be a little tighter. So I'm holding Control and clicking up. Let's bring that up to there. So this is going to be a very tight corner. And I can click that entire loop and I can Alt, so deselecting the edges I don't want. So let's have a super tight edge there, just for the sake of demonstration. And let's select this whole loop. We'll unselect the areas we don't want there, and we'll have a loose, less tense, curved edge on this side to see what that feels like, just to demonstrate the idea of what we're talking about. Click, 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 boom, 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 boom. Bring that up. Okay, let's hit the Turbo Smooth and see. So on one side, we have a softer rounded side, and the other side we have a very tight rounded side. Now you can even go under the stack and edit this thing underneath the stack. So there's a button here, show end result, and yet I should still be able to edit. It's a little hard to see, but I still can edit the original geometry and then see the end result. The computer's fast enough to do this kind of stuff. So this is a fun way to push and pull and edit your shape if you want to do really weird things. 3D modeling is a lot of fun. It is very easy to get lost in the weeds if you don't have a clear idea of what you are trying to do. I mean, this is kind of fun, isn't it? Isn't this giving us a very weird and interesting shape? You have a cube that's like exploding on the inside. How much fun is that? That's kind of, whoa, it's kind of clay-like, kind of fun. Look how slick that is. You see how those highlights are nice and clear? And we're getting these good light reflections. The light right now is just a default light within Max. But really interesting stuff. You have a nice, clear, tight edge on one side and then good reflections all throughout. So to show what it looks like without all that subdivided information, turning Turbo Smooth off one more time, and now the light is more ambiguous and the object is therefore less clear. See how the geometry is getting stretched out. So to demonstrate the problems if you mess up in sub D, for instance, let me intentionally make some n-gons and triangles. I'm going to create a cut at the top, and it looks like, oh, Tom cut out a quad. These are 4 edges. So let me get rid of the Turbo Smooth just so it's easier to see. Wow, so okay, Tom has cut a square. Well, inside of that square are 4 triangles. And then the object I cut before is actually 5-sided. This won't subdivide very cleanly anymore. It's going to have some errors. So let's see what that looks like. Okay, it's doing a good job so far. Actually, it looks like Max is handling this rather well. But we do have a bit of a pull. So where it's subdividing, this is now a 5-sided star. Otherwise, it's actually doing pretty well subdividing this. 5-sided is not too bad, but as you divide in, you kind of see that this point is still remaining, and it's catching the light in a very strange way. If we get rid of the grid, you can see that as I round the corner, there is some strange things happening with the where the light is being reflected. Let's jack this up even more and see if I can demonstrate really some bad behavior. What if we have, I've been subdividing so long that I'm let's take maybe a bunch of polygons. What happens if we really make some ugly geometry? So I'm gonna have this pole that's got a lot of lines coming off of it and some really strange triangles, intentionally making something kind of ugly. This is very ugly geometry where we have n-gons that have obtuse angles and extreme angles. So it's up to Max to figure out how to make triangles out of this. There is a button that shows the triangulation within the modeler. Let's see if there is a way to view that. Maybe it's under Edge. Let's find half of working in Max is finding where all the buttons are. There is a place somewhere to show edit triangulation. So now if I turn this button on, edit triangulation, you guys probably can't see it because my head's in the way. Let me move my head so you can see where the button is. Edit triangulation. Here we go, something like that. We can see in dotted lines what 3D Max is doing under the hood to try to resolve how to render this thing. Okay? It's making a mess. I made a mess on this top. What's it going to do when we turbo smooth it? Ooh, getting really ugly. Look at this. This cut there was probably an extra cut in there somewhere. It doesn't know what's going on. There's extra breaks. There's random shapes. This is going to be very ugly. So let's crank the iterations up a little bit. And now we have these little knots. As it tries to subdivide bad, unregulated geometry, it's coming up with these little knotty points. So what does that do on our render? It catches the highlight in a very strange way. Hopefully you guys can see this, that now instead of being a smooth surface, we now have these strange reflections that are hitting and skewing the surface of that geometry. So we have these ugly, ugly, ugly poles. That's what you want to try to avoid. So how do you solve this kind of problem? Let's say we wanted some more information in sub D. How would I clean this up? Well, I think I have to give credit to Andrew Kincaid, modeler who I met at Firaxis, for demonstrating these processes. If you start with the outer edge of a quad, you draw a line from the corner in, and then you begin to subdivide manually. I like to work messy to finish. So just by cutting from the corner towards the middle and then subdividing on either side, now I have a 4-sided geometry there, 4-sided geometry there, and then I'm going to begin to try to make loops again. So we have this point in the middle of this quad here. What I think I can just connect boom to boom because we have the corner of the original quad that's already subdivided to the middle. Now we start to have a loop happening here. So we're going to, this loop is terminating, but it is the beginning of the theory of a loop or a quad. Let's see, what else can we do? We have this point down here. This is kind of random. I'm tempted just to delete it, but if it's actually important to have a data point there, I'm going to continue a loop laterally around the outside. And see how easily I can just cut, and then come back around. I will cut through this point and then come back through there and then finish this in the corner. So okay, so we have solved that, but we still have a triangle. We have this triangular information. Let's keep going. Let's see what we can do. How do we resolve this guy here? Let's go to the corner. Does this feel good? No, that doesn't quite work. I have a quad on one side, but a five-sided object on the other. Let's start with a triangle. See how that triangle's better than a five-sided object. So maybe sometimes you got to start with just a triangle. We have a triangle here, we have a quad here, we have a triangle here. Sometimes you can just connect two triangles together and then solve your problem. So if this triangle, I also have this triangle up here as well. I could come through here. This is going to be crazy, but this solves it. Coming through the outside, corner to corner, corner to corner, and now these are all four-sided. This is four-sided, 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 four, 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 four. Very cool. Four there. There's a triangle here. Is there another triangle I can connect to? There's these four triangles in the middle. These are pretty ugly. What can we do with this? What can we do with this? Let's complete this around. Complete this around. This around. Let's see. Does this work? Does this work? I want to connect this to that, but it's going to be a little messy. Well, what we can do is take that to that, that to that, that to that, that to that, that to that. So the vertex is important. The edge to that vertex, maybe we can change that edge to that vertex. So let's go here to here. Let's try that. You say, Tom, this is looking pretty darn complex, man. I'm just trying to solve the triangles and get us back to quads. I can delete the triangle. I can click on the triangle and delete that. Here we go. Does this make sense? Not really sure. This is one of the uglier demos I've ever done, but that's okay. Let's bring... This is what happens when I start a demo without a clear plan of what I want to demonstrate. I just like to make a problem for myself and try to solve it for the benefit of the students. Let's see. Let's check on our triangulation, see how we're doing. So now when we turbo smooth it once, how is it subdividing? It's looking a little strange, but hopefully the reflections are getting a little bit more consistent, more predictable with what our shape is. We have this big pole right here in the middle where you have one vertex with many spokes coming off of it. That's really what we need to clean up. That's really what we need to clean up. We have a double triangle over here too. That's getting a little ugly. So let's go back underneath. What's that double triangle doing? Why is there a double triangle over here? Is there a bad data point? Yes, this happens sometimes. When you cut through, sometimes it creates an extra vert. I'm just going to hit backspace and delete that extra vert. Or you can also select all your verts. Hit one, select all, Control A, right click, and sometimes you can weld. Hit the weld button, and any verts that are stacked up can just be welded to themselves. We have 133 before, 133 after. Should be good to go, should be fine. All right, how's this looking? Everything's looking good. Hey, we got some comments. Let me read the comments real fast. Mel Pico says, woo! Ryan says, nice. I do a lot of this kind of hard surface modeling. Yes, Ryan, I know you do, and you're very good at it. Ryan says, 3D Max is great for hard surface. There are some new programs, workflows out there. I am a little late on the HIP Max stuff. Thanks for commenting, Ryan. Thanks for commenting, Mel. Thanks for letting me know you two are watching and are out there. Brandon checked in. What up, Brandon? He is recovering. I hope you're feeling better today, Breadman. What else we got? What else do we got here? Yeah. Oh, yeah. All right. All right, so we have a pole right here. This pole position is ugly. We want to have a couple fewer of these edges going to that. Let's get rid of this edge. Let's get rid of this edge. Just delete it. So we have these two triangles, but we still want that vertex because the vertex is our data point. That's our information. That's what we want to catch the light a little bit. And because we want to catch the light a bit, let's change the shape. Let's bring it out. Let's bring it out a little bit. Since we have a vertex, let's use it. Let's make it do something. Let's just move that vertex. Maybe it's like rounding the peak of this object. I don't know. Something like that. Okay. Trying to create topographic-like lines if you're looking at Zelda Breath of the Wild. So we have some kind of inconsistent loop action going on here. Let's try to make those loops a little more consistent. So I'm seeing that there is an outer loop here. There's a flow, an edge loop flow coming through. Let's see if we can do something with the flow. What does this do? Does this make sense? That's a bit stretched out. Let me break this somewhere else that'll be a little bit better. Let's try something like this. Is this terrible? Probably. You're like, Tom, what are you doing, dude? This is looking awful. Sometimes it's good to demonstrate how bad you are at something. It's very humbling. Let's do this. Let's take this here. Boom, boom, boom. Let's do that there, and then connect this to that. Boom. That to that. Boom. Let's get rid of that triangle. Let's say this is an important data point for some reason. Let's say this is an important data point for some reason. This is very ugly, but let's just maneuver a couple things. I want to have a cut in this area. Can I delete this? Can I delete that? Yeah, I can delete that. Let's finish this loop off. What if we did that? What if we did that to that to that? Boom. Is this cool? This is feeling good. This is feeling better. Boom, 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 boom. There. Okay. So we have a inner. We should have this. Should be a loop. That's almost a loop. What am I missing? Probably where I cut. Maybe there's multiple parts. Oh, I see. Because there's a pole. That's a pole there. Right? Yeah. So that's so a pole that has more than 4, I can't loop through. So because this has 4 edges coming off of this vertex here, it can loop through. When there is a division, so there's 5 edges, I can't loop through it anymore. But this should divide a lot better. Let's see. Oh, this one's ugly. Ooh. What's good is I can just cut that to there, that, and then this is now 4-sided. Boom. Okay, cool. We have a triangle here. How do we get rid of this triangle? What do we do, ladies and gentlemen? What do we do with that? If I do that, is that ugly? It's pretty ugly. Let's cut this. What does that do? I'm making more triangles. Tom, what are you doing? What are you doing? Running out of coffee. Let's just delete all this stuff because I can't take it. Select that backspace. What do we have? We have a loop. I see. So there's going to be a loop running along here. How do we finish that? I see. It wants to do this. It wants to come down and come back around. And then I can get rid of this guy, this guy. Oof, just making a total mess of things. This loop has to now come down to the outside again. And boy, is it getting ugly. This is the worst demo I've ever done. It is getting real bad. This always happens to me. This is why teachers need to have lesson plans. Because otherwise they end up in crazy Tomland with subdivisions all over. This is just getting out of control. Absolutely out of control. Terrible, terrible, terrible demo. And you all would be better for forgetting everything I've just shown you here. I feel like this is an Eric Andre show where I've tried to have a decent conversation and it has gone so far off the rails. How does this subdivide? What is our end result? Wow, we have something that actually divides pretty decently. This is a little bit cleaner. Let's crank it up again. Do we have any poles? Yeah, it's weird. It's definitely got some weird stuff going on, but it's not too. This is getting a little ugly in here. But the top is more or less becoming resolved. A little bit cleaner of a highlight. And there we have a pinch. So we can see this is the next problem that we would have to resolve. Ah, I see that there is probably multiple points here. Indeed, there's a pinch. There was a pinch. Let's collapse these two together. Let's solve this to make it a little bit cleaner. Sometimes we have to extend the loop out. This crazy geometry here probably needs some geometric support. So we'll just do a couple quick cuts to give us some more information. And then I know that was a bad cut. Let me fix it. Boom. Let's get that there. Boom, that there. Boom, this here. And boom, this here. Oof. Do you like seeing someone get stuck in a mess? What do you think about that? Ryan's got some links for me, like he always does. Excellent. Artemis 3D is great to learn more hard surface for 3D Max. You can also align XYZ, that is useful totally. I think Ryan needs to do some tutorials. What do you think about that, Ryan? Show us your stuff. Calling you out, chamferzone.com. Very cool. Very cool. Very cool. Let's see. Let's see. Let's see. Maybe Ryan does do tutorials. If you got a YouTube, you should share it, Ryan. Got some stuff. All right, we're going to solve this right here. How are we going to solve it? How are we going to solve this loop? Where do you want to go? Where do you want to go? You have to divide the triangles. We could do this. We can go this way. Go around that way. What does this look like? Oh, it's just going to be messy. It's going to be messy. Boom, boom, boom. Does this solve it? Whenever you see a 3D modeler that has more gray in their hair than years on their human meat frame, this is why. Because 3D modeling can be very frustrating. It's visual and it's technical, and no one comes out unscathed. See, to solve your problems, you have to get more and more complex. It's kind of like the U.S. highway system, isn't it? If you want to resolve to the corner, you got to go further and deeper. Delete that, delete that. Come here, come hither. To there, 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 to there. You may be asking yourself, Tom, why are you wasting so much of your time on this? And I would say that's a great question. I would say that is an awesome question. One for the ages of man, of time, of place, going down the rabbit hole. That's going to be my next podcast. Down the rabbit hole of ugly 3D geometry. Yeah. Okay, I'm getting tired of this. I'm gonna end this right now and show you guys what's inspiring bad 3D. Let's talk about bad 3D for a second. We're gonna talk about a YouTube video. I believe it's called is it Much Noise? Yeah. Yeah, man. This is bad 3D is like a surreal art form all of its own, where it's a release of the frustration of the 3D animator who does things for a living. And I think is Igor the band or the company? They did a video where they use mistakes in 3D for a visual effect. Igor, very noise. Ryan's asking, do you know how to make pipes? Oh, that's pretty cool. Pipes are cool. That's pretty good. I like that link, Ryan. So we are going to see how a music video uses bad 3D effects to create a wild character. Igor, very, very noise. Highly recommend. Okay, let's click on this, how the F do I model this link from Ryan. How the F do I model this? Talking about subdividing pipes and fittings and stuff. Yeah, this is great. This is a great example of some basic subdivision stuff. Yeah, man. That's the cool thing about the 3D world, is there is a lot of information on the internet. I don't think you need to go to school for 3D. I think you can just take online classes, be it from Animation Mentor or Polycount forums or Gnomon School, and do things that way. I'm really curious to see if maybe comment and think about this. Like, what will the future of art education be like? Because Micah is like $70,000 a year to go to Micah, and I had like 3 classes in 3D there. I learned most of my 3D from work. So why does this matter? Why does any of this matter? Let me give you a practical example of what I'm doing with this. So let's open up another file. Open recent. I've been working on a project. I don't want to show that project. Does not save this file. This file is not worth saving whatsoever. When you're getting into real time, you got to have that subdivision. So when you want to add sculpted detail out, ZBrush requires clean geometry really for good tessellation and good editing, because you want to subdivide to like 16 or 30 million polygons to do ZBrush sculpting. So if you bring in a base model, you want to have it clean and well looped out. But in video games, you want to have low poly because you got to render this stuff at 60 frames a second. So for instance, this model of a hearth, a stone hearth. Let me see, make sure this is coming through well. Looks like it's coming through pretty well. This stone hearth is generally, it's got triangles. It's got a lot of triangles, but no n-gons. Let's see how this subdivides. Turbo smooth. Let's keep smoothing groups on just to see what that looks like. And it looks pretty good. So as I crank up the resolution on this, it's still subdividing pretty cleanly. And that's what the hope is that you make a model that's clean enough that if you want to throw it into ZBrush, you have a clean enough geometric base that when you throw a turbo smooth on there and subdivide it, you could bring it into ZBrush and do all kinds of stuff to it. Apply a displacement map, apply a normal map, all that kind of stuff to give you some work, some base geometry that you can sculpt off of. Got to thank people who inspired me again. I'm going to mention Josh Hardy, Ryan Murray, Greg Furch, and Dave Black, people I'm thinking about when doing this particular demo. So to all my former mentors, thank you, and good luck in your current endeavors. Thanks for chiming in, Ryan, and thanks for chiming in, Mel. Ryan says, looks nice, Tom. Look, dude, I just had to show, like, I kind of know what I'm doing sometime, because I went so far off the deep end with that box demo. It went way further than I planned on it. I'm like, hey, come on. If anyone watches this video, they need to know that I kind of know what I'm doing when it comes to game assets. This whole scene, this environment scene I did was just to be a low poly, fun environment where I can learn. I did a concept painting for this, and I wanted to do more with the environment and model some trees and some bark and stuff. Haven't even gotten to the buildings and shed in the background. Here's the original concept I wanted to do to see if I was even interested in doing these kinds of things. And that's where this project is. It's been on the back burner for a while because I've been doing some other interesting projects. Thanks for joining me, ladies and gentlemen. I think tomorrow I might do a video on the current state of the Battle Royale Baltimore painting. Send me messages if you want to see anything in particular. This video will be on my YouTube channel, Turbo Symonds. Take a look at that, and I hope you have a good day. Peace out. Thanks, Ryan. Bye-bye.